Hello, everybody, and welcome to today's live session in the certificate programs in Python for algorithmic trading and computational finance. That is the introduction and overview session. I'm always excited about to get started all over again with the new cohort. We have planned for quite a bit of new content for this cohort, exciting new content, in particular in the area of AI for finance, AI applied to finance, but also in other areas. In some core areas, we have updated the codes and the content significantly, I can say, and more on this later on. I dive now already into the slide deck because I've planned for quite a comprehensive agenda. Here you see the points that I have planned for. So the introduction overview session is meant for you to gain an better overview, better understanding of what to expect during the program, also a better understanding of the single classes. We have quite a few, as you can see here in the list, but you should also get an overview of how the program is structured, how you can work through the single elements, for example, making use of the Quant platform, where we have recently released our version 2.0. We have been working on the new version since the end of last year, so pretty excited about this particular element. But also, I'm going to provide you with a few case studies and demos. They are just meant to whet your appetite and not as an instruction per se. So I'm covering quite a few topics which are involved in and of themselves. Some of the codes that you see are from later weeks in the program. So it's more for you to lean back and to follow along. It's not about instruction, not about understanding what I'm showing. It's more about, again, whetting your appetite. We will also discuss the study plan for the programs and the review questions, exercises, test projects, which have become a core part because they provide you with exposure to problems, more easy ones or more difficult ones, where you can test yourself, where you stand, what you have mastered already, and where you might review the original content. We, of course, have a user forum, the Quant platform, a few words on this. And I close, as usual, I must say, with the importance of practice, because we are going to cover lots of theory, but the practical parts and to acquire the skills, this is what is at the core of our program. Quick introduction. Most of you know what we are all about at the Python Quants, but here, quick overview. We provide services to financial institutions. We obviously offer training. We run platforms, not a single one. We have, beyond the Quant platform, also the AI machine, which is a platform for the standardized deployment of algorithmic trading strategies. We have open sourced quite a bit of code, libraries, different ones. In this context, I've written a few books, more on this in a minute. And here, of course, a certification, which this session today is part of, obviously. And we run quite a few events. And if you follow, for example, us on Twitter or LinkedIn, you might know that we run quite a few meetup groups, for example, and do also boot camps in general on-site and live, but these days more and more, obviously, in virtual fashion. I mentioned it already, the AI machine. This was an outgrowth of our endeavors in Python for algorithmic trading. It is a machine, and for those of you who are interested more in the standardized deployment of such strategies towards the end of the program, feel free to reach out and we can discuss maybe if you would be able to use the platform. Here, a quick summary about what we do. Most of the content should be already known to you that you have signed up for the program. But anyways, if you want to forward it to a colleague or a friend and say, basically, this is what I'm doing, this is the 2-minute read, which is publicly available, obviously, so easy to forward. For those who are interested in my background here, the long version, I'm not going into that, but feel free to read through it. Now we're coming to the books. I mentioned already I have written a couple of books. These are my Quant books. This is how I got started, my background, my PhD is in mathematical finance, and this is how I got into Python. So it was not the other way around. I started with the finance side and thought quite a while ago, more than 15 years ago, that Python might be a good language to be applied to finance. This is how I got into the Python game. And here you see the Quant books that apply Python. But I think I'm best known if we talk about books for Python for Finance, second edition, 2018. This has been translated, for example, in Japanese and also in Chinese. So I'm pretty happy that it's not only used by practitioners. I think the percentage points of people who read the first edition have been on the higher end for practitioners. But these days, more and more, it is used as a basic textbook at universities, even for undergraduate studies. And most recently, I got in touch with a group that uses it already at high school. So I'm pretty happy that ever earlier people get into touch with Python, and in particular with our niche Python for Finance. One of the classes is obviously based on this book. These are the two new ones. I'm still in the final phase, finishing touches here for Python for Algo Trading. Just today, I worked a little bit on the book. So finishing touches, as I said, that the main body is there. Artificial intelligence in finance is already in production. And when I mentioned before new content, this is part of it. So we have recently updated these core elements of our program based on the writing of the books and making the code more consistent, more reliable, and updates to most recent versions of TensorFlow. And this is always quite a bit involved, but now I think we have reached kind of like a good base version for all the codes that we offer you. And trust me, these are thousands of lines of code, hundreds of Jupyter notebooks that are basically usable out of the box for you. So this is always our approach: ready to use, consistent, self-contained codes. This is what we provide. The program itself is pretty comprehensive. It has grown over the years. 16-week program, 10,000 plus lines of code. I don't know. It's a while back that I counted really the lines, but 10,000 is on the lower end, I would say. The documentation has grown to some 1,750 pages that we provide out of the box, more or less. So it's quite a bit to cover over the course of it. 200 plus hours of instruction. We have quite a bit more, but of course we replace every once in a while certain elements of the program, certain classes, etc. So here you see another overview, of course, all based on the books. You will get access to gists, to GitHub repos, to all the codes on the Quant platform, and you have the documentation in the form of the books, and we provide most of it as HTML code on the Quant platform anyway. So no matter where you are, as long as you have access to the web, you will have access to all the resources there. And we've also tried to make it as mobile as possible. So when I answer, for example, user forum questions, I often do it from the iPhone. So this works these days. So with PQP 2.0, we not only changed the whole architecture, we tried to make it more usable from multiple platforms in this context. Yeah, but we go into details here anyways. But on a higher level, when we see what is going on out there in the financial world, obviously programming skills are key skills these days. They used to be kind of like a little bit exotic, and when an analyst, for example, said, well, I'm also able to program and crunch large numbers of data, this was kind of a differentiating factor, maybe competitive advantage compared to other colleagues in a bank or in a hedge fund, let's say. But these days, both on the buy side as well as on the sell side, this is something that is simply required. And if people come into analyst or associate programs at big banks, they usually go through trainings. And you see here the coding training for this year's juniors was based on Python programming, which helped them to analyze very large data sets and interpret unstructured data. Next year, so this was from 2018, and next year was already last year, the asset management division will expand the mandatory tech training to include data science concepts, machine learning, and cloud computing. So we must say that what we're going to cover, maybe not in the detail that you will see in our program, but on a little bit of a higher level, this is what the financial industry is expecting today from people working in analytic and quant-oriented functions. But already for credits, this is something that is in high demand, as we can see here. So credits with tech and finance skills. So the combination, right, the very niche that we cover, this is what is in high demand. And I myself, for example, I've been teaching at the University of Miami last year in the Master of Finance program, and the time that master students in finance spent on programming has increased tremendously, right? Back in the days, they used a little bit of Excel, maybe some VBA, and created some PowerPoint presentations, all fine. Maybe this is still required today, but mostly they use now what you see here are, of course, Python or other programming languages that are popular and demand in this context. So, and I said before, just last week, I have been in touch with a group that covered Python for finance at high school. So this is how far we have come, and I'm probably the most happiest guy around about this development. But overall, we can conclude that finance will need people who can work with robots as AI takes a third of jobs. You can say, well, this is all pretty bad, and artificial intelligence threatens certain jobs and job profiles, whole profiles, you can say. But for those who have the skills, I think this is a fantastic future to flourish in the market, right? To strive to supercharge your career when you say, well, I can program, I can do data science, I can apply machine learning techniques, I know about deep learning, I've covered reinforcement learning for finance. Then you say, well, this is like a fantastic future because I'm already used to it. I have the skills to navigate this new landscape that we see out there. Let's dive into the program. Quant Platform 2.0 is your central content and code execution platform. So when we talk about the content that we provide you with, it is about, for example, recorded videos. It's maybe also the recording of a session like the one today. You also find all the codes that accompany such a live session. You have the opportunity around the clock to post questions in the user forum, and not only our team is active there, in particular in the previous cohort, we have had many active delegates there. They help out each other, they have similar ideas, face similar problems, and we had like small user groups here. So this is something I can only encourage, that you make heavy use of the user forum. We have also a search function when you say, well, I have this particular problem. Probably there's something related already on the Quant platform. So you should also use it as a repository of answers to certain questions that others before you have faced as well. And then you have here, this is just like a screenshot of the navigation. You can, of course, have access to all the content like AI and Finance, Finance with Python. These are the written materials plus codes. And then you have the trainings, AI and Finance, tutorials, Finance with Python, Financial Data Science, CompFin, PyAlgo, all these elements. So I won't spend today that much time on the Quant platform, but we have created a video, which you'll see here a screenshot from. And behind the screenshot, there's a link. So there's a link to the video itself, some 15 or 11, here you see 11:45 minutes. And it explains the basics. So whenever I say, well, oh, I've seen this once, but I can't recall how, for example, I save a Jupyter Notebook in my own folder structure, this is where you find the explanation for that. Maybe not every single detail, but since we rely on Jupyter Lab, and I will show this a little bit later, since we rely on Jupyter Lab, this is a standard environment. So I'm so happy that Jupyter Lab has added so much functionality that we ourselves have programmed and maintained. This is the large effort when you implement something on your own, maintained over years for PQP 1.0. And I've been so happy that the Jupyter Lab team have come up with this fantastic environment where you have lots of file management capabilities, and more is added to this whole context, so that we decided at the end of last year to build something new on top of Jupyter Lab. But you will see it later on here. In any case, if you click on it, it will lead you to the YouTube video, and you can follow along for like some 12 minutes and see the major elements that you can expect on the Quant platform. And it explains also the core elements. Finance with Python is, I would say, the most fundamental class course that we have. It is about a gentle introduction to finance, Python, and a combination of both, because we have many people who have a strong finance background and have done some programming. For those, they know probably all that is presented there in terms of finance, but then they can relate it immediately to pretty straightforward and simple concepts in Python. Then we have like the programming professionals that want to enter the finance field. They know about all the programming, but at the same time, they see what this represents in the financial world that is coded there. And then, of course, the combination of both is what characterizes our program throughout, right? So there's not that much that you find in the program, maybe beyond a couple of games in the reinforcement learning context, which is not targeted towards finance. So here we cover really the basics like static two-state economy, fundamental theorem of asset pricing, a static three-state economy to cover market incompleteness, static multi-state economy, dynamic economies. But there are a couple of things that we already introduced there which can be considered advanced. Like, for example, in the context of dynamic economies, we cover binomial option pricing, we cover Monte Carlo simulation, static multi-state economies, we cover the static theory that is typically cast into the setup, like mean variance portfolio theory or capital asset pricing model. So many of the popular traditional, or as I like to call them, normative financial theories can already be analyzed in this context. And even if not everything at the first pass, at the first read is completely clear, this is what I always emphasize. Just lean back, focus on the red line, see the major topics, and don't spend too much time on a certain detail. So I observe this over and over again that people say, well, I have like the requirement that I understand at the first pass everything that is presented to me. We present simply too much, I must confess, for somebody who is just starting out and want to cover the whole program over 16 weeks as we plan for in the first try, in the first run. So rather plan for a second or third iteration where I say, well, okay, I got the big picture, and I might go back and revisit some details that I didn't cover during the first run. So here you see an overview. I'm not going into the details because they are explained during the programs anyways. There's a little bit about Python installation, Docker usage, cloud usage, and where is this ending up? This has nothing to do here. Sorry, this is this has a wrong location here. I'm sorry. I will reorder that. Here we see the finance with Python part. So on the left-hand side, this is at the core of the core, right? This is the text. The text has, as you might guess, lots of text, but not only text, of course. We have in finance also quite a bit of math, and we have also the codes. But you're not expected to copy the codes and type them on your own. No, we provide all the codes. So here you see like the class itself, Finance with Python 01, Finance with Python 02, Finance with Python 03. So there are different sessions, different modules as we call them. And for every module where you find the video, you also have all the codes, and you can execute here the codes also on the Quant platform. So that's the basic idea. You have text, explains everything. You have the recordings for the classes where we don't have live sessions, where you can listen, where you can see. There are many classes where I do live coding, where the code is developed on the fly, but you have both the static versions of the codes, but also the live coded ones available to you, right? So this is what we have. And we have the execution side. And I have the demos and the case study a little bit later on, but when I show you this now on the Quant platform, because we are talking about it later, I won't go into that much detail. When you're here on the dashboard, you see latest video, you also see the latest forum post. This is just for easy access. But when you have a look at the study plan, for example, and there's something about reading in finance with Python, here you see on the courses, when I click on it, you see one of the screenshots from before, right? So you have finance with Python, and here you have the text where you can scroll down. On the left-hand side, you have the whole structure. You see, this is pretty granular here. So there are shorter sections, let's say here financial assets, financial assets are introduced as a financial concept. There's a little bit of math involved, obviously, because I like to call finance an applied math discipline, many others as well, I would say. And here you see the code. So you can read the code, there is an explanation for the code, but by no means you're now expected to copy this or to type this. You can do that. Some prefer that way. They say, well, I want to type this out. For me, that's the best learning experience, right? But you have access to the codes. But not only that, so when I close, or let me leave it open for a second. So I can now go to trainings when I say, oh, I found the text, Finance with Python, because I highlight here Finance with Python. Of course, we have much more, but this is what you are supposed to get started with this week. So this is, it lays the foundations for everything else. So under trainings, you find also Finance with Python. And when I click on Finance with Python, you see that now what I call the modules or the recorded sessions show up. Finance with Python 01, 02, 03, 04. And here you see also the codes. There are also links to the slides. And when I now go and say, well, oh, in the study plan, I see Finance with Python 01, then you can click on it here and you can get started. So let me mute it, otherwise I will hear it myself here. So this is the video. And in the video, you will see I do quite a bit of live coding. In particular, in the beginning classes, I try to provide you with like, a development from A to Z so that you see how the whole structure is built up and how the different concepts are related, right? So of course, there are explanations for everything there. So these are the videos, right? Again, you can follow along. That's one of the ideas why I do often live coding. Or you say, well, let's have a look at the codes. And I have opened already Jupyter Lab. So when you see here, you have Jupyter Lab. I have opened it already, I guess. Yeah, here I have it. And for me, program, for example, is an individual folder. So when you get started on a Quant platform, there's nothing that says program, right? But this is where I store certain things that I've created there or that I use during live sessions. But for the courses, you have seen the text before. Here is the text, right? And we have been in 2 here. I went to financial assets. So this is where we are, right? Financial assets, 213. And I can now go to FinPy 02. This is what accompanies the text. And while this is loading here, yeah, we see it now. And you see here time, money, cash flow. And let me see where I find financial assets. Here I find them. And this is now the part that we have seen in the text, right? So here we have S0, S1, S. And this is what we have here as well, S0, S1, S. So this is exactly the location. So I can execute this. I've just used a shortcut to execute everything above. And you see this is now exactly the code that we see in the text. So no need to copy this or to type it. You have it available. But I encourage you, of course, to practice. But I think it's not really efficient to type everything out that you see in the program. That's well too much. Now you might see it doesn't save here. So what we provide you here with under courses and trainings, these are like the original versions that we have control over. Now you might be working in such a Jupyter notebook and you might say, oh, well, I want to save my changes, for example. Then you can go here and say File, Save Notebook As, and here you see the path. And I now simply delete the 2 folders. And I can save it. I can't save it here because these are write protected folders. And when I go back, you see now, this hasn't been there before. My copy of this Jupyter notebook has been saved to my root folder in my Docker container because the Jupyter Lab instance here is run in a Docker container for everybody who's launching Jupyter Lab. This is all completely containerized. And now I can say, okay, I save it, I add something, I play around with it, I make notes, whatever. Now you have your own version. You can, like myself here, create another folder. You see here AIIF, subfolders, and can save it also in the folder. But these 2 courses and trainings, they are right, protected. So you get access to all the codes on the platform. Of course, under trainings, depending on what you have booked, you see a bunch of things like here under AI and finance, you see the AI and finance sessions and the reinforcement learning sessions. This is one of the larger trainings, obviously, quite a few, 12, a total of 20. Sessions there, and when you click in there, you see, for example, here Jupyter Notebook plus a bunch of Python scripts. Of course, when you see a Python script, you can use and edit it here as well. When you say, oh, well, this is something I want to use locally, this is just an example, maybe you would need some other files, you can always do a right click, and then you see that you have basically all the file management capabilities that you might be looking for. So I can duplicate that, I can copy it, I can delete it. Maybe I don't want to delete it here. I can't even delete it in this folder, but in my own folders I can. But you can also, for example, download it. So when you say, well, I want to use this locally, you can download everything that you find here on the platform. Just a few examples. You have also, of course, the link to the video. This is now saved. So when I say, well, I've worked with my copy, here it is. This is still running. I might say, okay, I shut it down. I'm finished. And I don't even need it anymore. So I would say, for example, delete it. Right? We always provide hints to where you find the PDFs. But here under courses, I've been there, FinPy before. Here you can open PDF for reading as well. And these are password protected. Everybody should have received the passwords to it by email. I want to provide the proper password. I also have a PDF version, which can also be downloaded, right? When you say, well, I want to read, for example, on the iPad, you can download this here. Same way, download it locally, share it with other devices that you use, right? So same text as we have seen before, HTML, but here now as a PDF that you can share with other devices. Yeah, maybe that much about the Quant platform at this point in time. Here the text. When I'm finished, I can close it. So you have text, you have videos, you have the files that you can click from here. You have the execution environment. I've also shown you how to open the PDF. And this is basically how you would access stuff that you find in the study plan, which we cover a little bit later in the first week. And this basic structure you will find for most of the classes, not for every class. Not every class has, for example, its own text or even book these days, right? Not every class has only Jupyter notebooks or Python files. There are some that have like external resources, for example. But the basic structure, the basic approach remains the same. So now we are in Tools and Skills. And in Tools and Skills, I don't know, for whatever reason, this is the slide here, which was which is placed in a slightly wrong position. In Tools and Skills, what we cover, and you see it here on the left-hand side, we start with the basics. We cover Python installation on the two major platforms, Mac and Linux, which are pretty similar, on Windows, and we also cover Docker usage, Jupyter Notebook. So this is always what we would install, Jupyter Notebook, Jupyter Lab. Both are similar to be installed and set up. Cloud usage, this is what we also cover intensively. And all these topics, which are pretty fundamental, are covered for the two major platforms, Mac and Linux, as well as Windows. What we would expect, and what I can only recommend if you work on Windows, that you at least make sure that you have Windows Professional 64-bit. With the personal, student, home editions, many things that we cover simply do not work because they differentiate between the worlds, the pro world and the private world, so the personal world, so to say. We also cover basic Linux tools and shell basics, because once we have mastered the setup here, we usually work in the Linux world. So no matter whether we start on Mac as a local OS or Linux as a local OS or Windows as a local OS, we, from that point on, usually work in the Linux world, where we cover code editing with Vim, where we cover lightweight tool chain. We cover important topics such as doc test and unit test, Git version control, Python packaging, documentation, code hosting, and case study. So this is something that runs in parallel to all the other classes. I would recommend that you at least cover the basics in the first 3 weeks, because you will need this over and over again. Even if you are not willing to work with Vim, let's say, as an editor, the rest here is pretty important, right? Git is also something that is important, but for example, you could skip that for a little bit later, let's say, but the first topics here, they are pretty important, right? So and in this context, what we are striving for is to use Jupyter Notebook. Of course, we need Python underneath Jupyter Notebook or Jupyter Lab more and more these days. That's for sure. So this is a tool, but we need the language interpreter. This is Python. We can set this up on a Docker container. We don't have to, but we can, for example, locally use Docker containers. But when we, for example, go and deploy automated algo trading strategies in the we typically use cloud instances, because from my point of view, A, they are cheap, so you can get started with like $5 per month, and B, the security characteristics and the reliability are unbeatable as compared to local machines. Trust me, I have a couple of, I wouldn't even say powerful machines here locally, but I would never deploy something on a local machine with my shaky internet connection, etc. So if you want to run something 24/7, you should make sure that you have proper infrastructure. And proper doesn't mean expensive. So you can get started, as you see here, for $5 per month, and you have already a professional, not only proper, you have a professional infrastructure. But more on this in the respective class. And the structure here, as I said, is similar maybe, but not the same. So here you see the videos that are provided, but we have here more external resources in the form of scripts and other hints and helper links, etc., so that you can make use of. That's the basic idea here, because this is something which is not only about Python code. We need quite a bit more and quite different things for the tools and skills class. It's all targeted towards Python deployment application, but it's not at the core about Python. The core is here, the infrastructure, the frame, so to say. That's the characteristic of this class. Python for financial data science is one of the important classes. This is based on the first 13 chapters of Python for Finance. So Python for Finance had a little bit more in terms of algo trading and computational finance, but we go much deeper in terms of algo trading and computational finance than what the book allows. So therefore, we cover the first 13 chapters. There's been a question whether other cloud services can be used as well. Yes, they can, but you will see that the classes and the materials are based on DigitalOcean, which has proven to be one of the most simple providers and also one of the cheapest one out there. So I know people might have been working with Microsoft Azure or maybe more often even with AWS, but this is quite a bit more involved compared to DigitalOcean. Maybe you give it a try for DigitalOcean. You get usually a free starting budget there, and then you can change and shift later onto other cloud services. That's for sure. So we don't have a contract with them in that sense, but for demo and training purposes, they have proven to be unbeatable over the last couple of years. So Python for financial data science, this is really when you say, well, I'm dealing with financial data. What do I need? Oh, well, I need Python data structures and data types, of course, something that I need to know of. I need NumPy for numerical computing. I need pandas for data analysis, maybe a bit of OOP. Of course, I want to visualize the data. I want to work with financial time series, which is pretty important, which is the paramount, which is the core type of data that we work with, financial time series data. I need to be able to tackle input-output operations. Maybe I face some performance bottlenecks. So what are performance approaches? And of course, in finance, we need math tools. We need stochastics, for example, for simulation, and statistics and machine learning. And last but not least, dates and times are obviously important. when you think of financial time series, oh, well, there's quite a bit to deal with in terms of dates and time. So this is what you can expect here in this part. So the structure again is basically the same as before. So this is now the standard structure. You have the text, you have the sessions plus the codes, and you have all the codes. You see it's quite a bit more as compared to Finance with Python. It's also some 500 pages in the book that are covered here in detail as compared to 150 in Finance with Python. Therefore, this class basically goes from the beginning until the very end, right? So it's a little bit more comprehensive. There's a question with regard to the PDF. So what I can say is that everything that's available as a book, we don't provide as a PDF. So because there are obviously copyright reasons, and I have signed, or the company has signed contracts in this regard. Everything that is, so to say, under our full control, like Finance with Python, you get a PDF, but for the others, we can't provide that. What I always recommend is that you subscribe, and I think the price is fair, it's not the cheapest thing in the world, but that you subscribe to learning.o'reilly.com. There you get access via a single subscription to not only all my books, which you can download on an iPad or another pad to this end, but also to hundreds, if not thousands of other nice and important books. Also the text Python for Finance, this should be roughly the same content. There might be minor differences. We had just another reprint, which might not be reflected, but if there are differences between the print version and the HTML, they are minor, they are not major. This is what I can assure you. There's a question about what machine learning, deep learning tools might be required. Yes, for sure. I mean, but there are not too many, so I can count it at 3 fingers. So we will use scikit-learn in machine learning. We will use TensorFlow and Keras. That's basically it. So that's what we are going to use. But good questions. But I think the answers will either come or will become clear once you get started with the respective classes. So this threefold structure is again here in its pure form, Python for Finance. Python for Excel is an optional class. Recently we had many people obviously pretty much interested in, and heavy users of Python for Excel. I've just started to brush up everything again here in this regard. So I'm planning, I think the materials that we have in the class are still up to date to a large extent, but I've planned for coverage of selected topics of Python for Excel in the mentoring sessions, for example. But I know it's still one of the go-to tools in the financial industry. Excel is there to stay, and even if I might not be the biggest fan, number one out there, when you want to combine it with Python, this makes for a pretty powerful combination. In particular, when you compare it to VBA usage in this context. There's a question. It's also good. Well, what is the difference between Python for Finance and Finance with Python? Yeah, Finance with Python really teaches finance, right? So this introduces fundamental concepts such as cash flows, discounting, interest rates, financial assets that you've seen before. Python for Finance basically assumes that you know quite a bit about finance and shows you how to apply Python for finance. Also, of course, I mean, the one is a gentle, short introduction, 160 pages. The other one, my Python for Finance book, is 710 pages. So this goes pretty deep in the final part of the book, even into complex option pricing theory like Longstaff-Schwartz, Monte Carlo for American options based on Monte Carlo. So I would say that's the way I've structured the program. This is my thinking, right? Finance with Python is like the introductory text, and then you are well equipped to get started with Python for Finance, which expects in both areas, Python and finance, already a little bit of background. That's I wouldn't say the difference, but this is how the two of them relate to each other. Python for databases is another optional class because, of course, in finance, as in many other areas, you deal with large data sets. Now, people say sometimes, oh, well, who uses MySQL? I can assure you that SQL technologies are still widely used. So maybe if you were a person who said, well, this is not my favorite, but maybe one day in the future you work for a company or in another capacity with another company that still use relational databases, but it's an optional class. So the same holds true for Excel. If you say, well, I'm not planning to use Excel in the future, that's up to you. These are optional classes. They're not too long, but they cover the basics. What is pretty interesting here, I guess, even if you're not on the database side here, be it SQL or NoSQL, like MongoDB object-oriented database, PyTables is a pretty interesting technology. SQL Alchemy, when I say on a Python level, I have an abstraction layer for SQL, or bcalls, which is a pretty specific a package there for columnar data storage, pretty fast, high performance, compression, etc. So that's, I think at least this is interesting. You don't need to work with all of these technologies, but SQLite is something I use also regularly, although I'm not an SQL guy, for example. You see also comparison in terms of performance and data overhead and etc. in this particular class. So this is something, for example, that I wouldn't recommend that you execute it locally or try to implement it locally, I'd rather say, or on the Quant platform. At this stage, you should already be able to set up a cloud instance, and we provide you with all the scripts and all the necessary ingredients to set everything up in the cloud. Because you work with larger data sets, you want to install MySQL when you follow along. So this is something that comes at a later stage where you say, well, I know already the basics, now I can set up everything for proper database management in the cloud instances, for example. There's a question with regard to the exercises. I'll come to the exercises, and short answer, yes, there are exercises where you can check whether you have absorbed everything. Natural language processing, a short class, but I think we cover quite a bit. We also provide quite a bit of helper functionality in this context, which allows you to work with unstructured data. And unstructured data is becoming more and more important, right? So it's not everything about numbers and dollars and currencies or whatnot. There is so much data out there which is unstructured and text-based that this is really also a key skill in our domain, right? And we might add a little bit more in the future, but at least this is a good starting point. And from what you see in this class, you can more easily venture out into other directions. So NLP, text processing, pretty interesting and important topic as well. But now to one of the core topics. It started out as a subtopic of algo trading, and it has become one of the core classes in the whole program. So artificial intelligence in finance, it is based on the book. And in finance, we're going to have live sessions based on the new content from the book. But I can say that this is my typical work style, that the book itself is an outgrowth of the AI in finance class that I've done last year, right? So I've prepared the codes, I've implemented a couple of things, I've got feedback from delegates. And with all of that, with all the experience, I then sat down and wrote a book about it. So I didn't start out like with the first word on page 1. So when I got started writing AI in finance, I had already, I don't know how many lines of code and how many Jupyter notebooks, right? So this is usually the way I work. This holds true for the other books basically as well. So usually there's already lots of code there, but of course writing it down as a consistent, coherent book, this is a different task. And this is all driven by the idea that financial markets are basically large abstract data processing engines or machines. Of course, there are humans that act in the markets, that's for sure. but it's a rather abstract thing that we can't really touch. We talk about NASDAQ, we talk about here, but all the banks, all the buy sides, all the players, all the market makers, all the machines, all the retail traders, all the brokers, they all play a role. There are humans involved, there are many machines involved, there are many algos involved. And in the end, what happens is that we have X, which is the input data that we observe in the markets. We have maybe terminal from Bloomberg or from Refinitiv, see new data, and people act, or the machines act, right? And what is coming out are new prices, are updates, the index goes up or down, the currency rate goes up or down. You all know about that, right? But it usually happens in a non-linear, complex, and changing way. Finance history, I was talking about the finance basics in the context of finance with Python. Finance history is driven by simple theories, right? So it all starts, maybe I say, maybe not completely correct, but I think fair enough to say that quant finance started at the beginning of the 1950s with Markowitz introducing his mean variance portfolio theory, right? This was for the first time that somebody said, well, don't analyze the fundamentals of stocks, don't talk to CEOs, don't employ armies of analysts and portfolio managers, just have a look at the price statistics, first and second moment, so returns, expected return, and the standard deviation, the volatility, and only with these characteristics, plus correlation, of course, you can set up nice portfolios that are supposed to outperform maybe others that are formed based on different approaches. So normative economics usually starts with a bunch of assumptions, axioms mathematically, and ideas about how people might behave in the world and how markets should behave. So should means here normative. This says how the world should behave and what people think it would behave. And then they come up based on the simple assumptions and axioms, they come up with simple and elegant theories, right? So some capital asset pricing model, linear regression, etc. So this is all pretty simple. But history from the beginning basically has shown and proven that most of the theories don't have significant empirical support, or the other way around, we hardly see any supporting empirical evidence in this context, right? This brain-driven approach, which I also like to call the beauty myth in finance, hasn't proven to be too good, right? Basically, it's in many areas, it's pretty bad. So the idea of AI in finance is that we have a look at the data. I mean, we are living in the age of data, data science, big data, machine learning, AI, right? So we have a look at the data. All these theories, most of them, they haven't been based on any data at all, right? People said, well, assume that investors behave X, Y, that. Assume that they only care about risk return. Yeah, but if it's not true, the theory fails immediately, right? Without doing some empirical evidence. Here we have a look at the data. We simply work with data. Then we apply general parameterizable trainable algorithms, whatever this might be, deep learning, standard machine learning methods, some others, right? And this might, there's no guarantee, but this might show good performance, but black box. This is what people say. Yeah, I don't like black boxes. I rather like to understand the theory in full. I like this as well, but when it's my money that is managed and that I trade, I rather have something that I don't fully understand as compared to something that works. So I like to make the difference here when you have a look. When you're driving the car these days, everybody is used to Google Maps and your navigational system, right? Maybe not everybody is able to understand fully how special and general relativity is required to come up with a proper navigational system, GPS, etc. So for most people, there's a black box, right? Navigational system is a black box because they are not professional physicists, or nor do they have in general PhD in physics, right? But anyways, they use navigational system, although they don't fully understand how it works, right? You can say, well, printed maps is something that I understand, right? There's a map that's printed, and you can stop the car and read the map for half an hour. But nevertheless, we rely on that, and this is my analogy here. So it's good to understand something, but if you're something that is performing much, much better, you might end up with something like a black box, right? But this is a discussion for maybe another context. We have a relentlessly practical approach to that. So the goal is replacing normative finance by data-driven AI-first finance, right? You again have the full text. This is here. There was a question whether the printed edition and the HTML version differ. Here, currently what you see is the latest version of AI in Finance, which went to production. So there might be some typos or whatnot that are corrected, but code-wise and content-wise, this is the latest version that I have available currently. So you have access to the latest version here as well. It's also the early release version on learning.o'reilly.com. You have the video sessions, AI and Finance. Here there are 12 sessions. And of course, you have the codes. You have all the codes. And there's lots and lots of codes. The Jupyter notebooks here are pretty long. So you will see when we go through it what you can find there. Here, I must say, we do this cohort another round of live sessions with the new content. What you find already on the Quant platform, AI and Finance 1, 2, 3 until 12, this is from the previous run, which was before the book was finished and before all the content has been updated. But I would say that still the two together make for good companion, because in the original live session, I focus much more on building up neural networks from scratch so that you understand what's going on behind. And at least on the coding level, it's not that much of a black box anymore, but rather maybe a gray box, a light gray box at the end. This doesn't mean that you fully understand what a network is doing, but you might much better understand how neural networks behave and what they are all about. Because when you can implement them on their own, I think this is like a perfect prerequisite for a good understanding. Reinforcement learning for finance, one of, I think, most exciting topics that we cover, because this has become even a mainstream topic, right? It started, let's say, some 7-8 years ago. This was one of the major breakthroughs when DeepMind was able to play Atari games at superhuman levels. Not every Atari game that was ever published, but many of them based on deep reinforcement learning. And of course, AlphaGo, the story of AlphaGo, and when AlphaGo was able to beat the world human champion. This is something that has a Netflix documentation. This is documented in many popular books these days. So I think almost everybody has at a certain point heard about these breakthroughs. And they are usually celebrated as major AI breakthroughs, but most of these, they go back to the application of reinforcement learning and not in general to general neural networks, let's say, right? So the reinforcement learning as a specific approach to attack such problems is what has proven so successful there. So here I said usually almost everything that we cover is finance related and targeted towards finance. So you could say we are almost single-minded in this context. But since this has its origin, reinforcement learning or Q learning in particular, in the gaming area, so we cover a couple of games. I think first and foremost because simply it's fun. So because once you understand how it works in this context, I think you have a much better time and easier time to apply it to finance as well in this context. Here there are links to some videos, for example. Maybe I show you the lunar lander. This is something, the context of one session that we do in reinforcement learning. I can roughly recall when I was a teenager playing this game there, and the reinforcement learning agent, you see, oh, it's not the fastest one in the world, but it somehow, uses the different actions that are available there to land the thing. It's not the best. It's one successful try, but you see, it's pretty slow. Probably you can do much better, right? So it will land there, but not maybe as fast and as accurate as you have seen recently the landings by SpaceX, right? So the SpaceX rocket ship, this was landing like on point, pretty quickly, straightforward here. It takes a little bit of time, but it's landing. And this is done by an algorithm, Q-learning agent, deep Q-learning agent that has learned to control the ship, and after 410 actions, it is able to land the ship without crashing it, right? So this is just like a rough idea of what to expect in this class. Content, as before, lots of code, videos, recordings, plus the option, of course, to execute it on the Quant platform, or you can download it and execute it locally. Python for algorithmic trading. We are now coming to the core class. There's been a question about how to best proceed, and I will discuss this in the context of the study plan, because the study plan is your map, even if it's not printed, but this is indeed your map, which is static, apart from the instances where I'm going to change and update it. But here you see a core class, and they start basically from week 4. And this is the other book coming out this year, towards the end of the year. And yeah, this is content that we have created, maintained, improved, updated, upgraded over a couple of years. So this used to be the core of the Algorithmic class from the beginning. Again, the trainings, the notebooks have been there first. Then this was kind of like put into a coherent text, including codes, math, and everything. And this is now coming out here as well. And you have here also access to the latest version that I have available. So maybe there's a little bit of lag, like 1 week, but this is what you access there is the current state of the text plus the codes in this context. Foundations, you see it on the left-hand side for this class, finance with Python from 1 to 4. This is what is expected. Of course, financial data science, ongoing, and here with a particular class is what you should cover. Then we have the specific topics, vectorized backtesting, prediction-based trading, where we use machine and deep learning, event-based backtesting. And once you want to get started trading, you need to deal with real-time data and streaming. And once you master socket communication and real-time data, for example, in the context of real-time data visualization, so streaming data visualization, you need the platforms where you can execute code. Without code execution, trade execution, of course, the code needs to be executed such that the trades are executed. There is no algorithmic trading. You might have algorithms, but you need a platform to execute your trades. Wonder, FXCM, Interactive Brokers, Gemini are the 4 platforms that we cover by default. Last but not least, you see here automation and review. Once you have put everything together that is important in this context, you might want to deploy this in the cloud. You might want to run it for maybe not only a few hours, but maybe a couple of days, 24/7, depending on the instrument that you trade. You want to monitor what is going on. You want to use logging, for example, to make sure that you always have all the information to, for example, debug the code or see what has been happening. So this is a pretty important part, and this is the goal. Cloud deployment, automation, this is, I would say, hard, but not too hard. So the whole program with regard to Python for algorithmic trading has this particular target. Then we have practice modules 1 and 2. So the first is about coming up with your own strategy, and it's not about having the best performing strategy out there and beating the big hedge funds out there. You should get started working with your own idea. You should backtest it. You should get a good feeling. You should deploy it maybe for an hour or 2. And the second module is to deploy it in the cloud and to let it run for a longer time. And we always see that as easy as it sounds, in particular when you have mastered the basics, there are a couple of hurdles that you need to take, but we provide you with all the skills and all the resources that you need for that. And this should then naturally lead to a final project. The final project is, in its style and approach, a research project, which means that it's not about trading. So you cannot say, well, I have this strategy, I do a live deployment, and that's my final project. It's not. So you should target, and you will get all the details that are required, even access to an example project, which was created good in this context. You should write a paper which I can replicate one by one on my machine, because I think this is clear, I guess, I hope, that when you implement a trading strategy and let it run for, let's say, the previous week, your project has been implemented over the previous week, you send it the week thereafter. How shall I reproduce that? I mean, the previous week is simply over, right? I cannot go back in time machine, time warp. This would be nice, and try to retrade what you have been doing. So it needs to be a reproducible research, but the details are provided at the right point in time during the program. You shouldn't worry too much about the final project. I know sometimes people, even in the worst week, in the first week, say, well, what about the final project? I said, well, focus first on your studies, and then when time comes, we provide you with all the details. You will then send in a title and a detailed abstract, and once you get a go, you can get started on it. So here we cover the 7 layers in the Pi-Algo pyramid, as I like to call it. Infrastructure first, financial data is of course required. We formulate the strategies, we backtest the strategies, both vectorized as well as event-based. We cover the socket streaming world, the real-time visualization, for example here, then the trading code based on 4 different platforms for crypto, for currencies, for CFDs, and quite a bit more. And last but not least, this I would say is the highest level, is the automation, when you say, well, now everything fits together and I want to let it run for like a week or 2 on it. So we usually offer the opportunity for those who have done thorough research, who have deployed it, who have proven that they're able to do it, also access to the AI machine, but this is on an individual basis. So we should, if you're interested in something like that, where you say, well, I've come up with this fantastic strategy, we should discuss this later. Python for computational finance. This is about the numerical methods that are required to do proper option pricing, hedging, calibration of models. But before I dive into that, there's been a question with regard to statistical analysis of algorithmic strategy. Yeah, we analyze strategies to, I would say to a large extent, maybe you have more comprehensive ideas in this context, because depending on the strategies that you implement, there might be other analysis required or helpful in this context. But we do an analysis, for example, with regard to risk, like value at risk, like with regard to drawdown, maximum longest drawdown periods, and quite a few more. So we do that, but for example, not in a portfolio context. So now I was thinking of something that we don't cover. So usually our setup here is that we think and speak and implement in terms of a single strategy. Of course, when you want to deploy, let's say 5 strategies, there are other relevant aspects that come into play. So this is something where I can exclude that at the current state of the program. This is, for example, not covered comprehensively. We cover capital allocation according to the Kelly criterion as one example, but also typically targeted towards a single strategy in this context. So Python for computational finance. This is based on something that has grown over years. I have given university lectures over years based on the topic. We have done consulting work for hedge funds in New York, for example, based on what we have here, where we have also applied and deployed DX analytics, for example, for pricing and analytics. Here see also the Chinese translation of the book. So it's indeed a global topic. And this is quite involved. I would say from everything that you find in our program, that you see in the program, this in terms of mathematics and finance theory is the most demanding class. But I think this comes with the topic, and usually or mostly people come to us for algo trading. I know that most of you anyways do the platinum package and cover the 2 topics at the same time. But we have also many delegates over the years who said, well, I focus maybe in the first run, I focus on Pi-Algo trading, and I do, for example, computational finance later on. But you don't have to. So this is basically up to you how you want to study this. So this is all about market-based valuation, right? We covered the basics like complete market models, binomial option pricing, Black-Scholes pricing. We cover risk-neutral valuation, Fourier pricing theory, pretty involved mathematically. Also American option pricing, pretty involved numerically, right? The general market model, where we have elements such as jump diffusion elements, we have stochastic volatility, stochastic short rates, correlations between the single elements. So here we're going quite a bit deeper compared to the standard topics that we cover in Python for Finance and in Finance with Python, for example, because there have been questions before, how do they relate to each other? Here we go even deeper in many areas compared to the other classes and books and topics, right? But the Monte simulation is covered in detail. The calibration of these models, hedging, review. I have a few examples in this regard. For example, the calibration of a model is one of the demos that I have prepared. So therefore, I don't want to spend too much time here. We have all the codes anyways available in the GitHub repository that accompany that, but the class itself has quite some differences to the codes from the book as well, but it is basically based on the book. And we also cover in detail DX analytics. So this whole class, computational finance, has two streams. The major stream, which covers the theory plus the pure Python implementation from scratch. And then we have the second stream where we cover the same topics more or less and a bit more, I can say, based on the open source package DX Analytics that I've written or started writing a while ago, and that is open source and that you can install there as well. So this was basically an outgrowth of writing the book itself and later on applying all the techniques in a practical production context. So that's the background, but you have the two streams where you see theory, you see the implementation, and then you also have the package where you can apply what you have seen in another context. There, of course, the package has like a comprehensive documentation. We rely on most of the Jupyter notebooks there, maybe not on everything that is there because it has grown over time quite a bit, but most of what you find there is that you get a thorough introduction and overview of the whole thing. So here you see a rough overview. This is explained in detail. It's all based in DX Analytics on Monte Carlo simulation of cash flows, optimal exercise policies, and risk neutral discounting play a role. We have the non-redundant modeling of risk factors. We can have European American derivatives, simple one with a single risk factor or complex one with multiple risk factors. We can have different positions with different sizes. And then we also calculate, obviously, the net payouts for the portfolio. We can model constant deterministic and stochastic short rates. This is just like a schematic overview of what DX analytics can do, and it can do quite a bit more. This is more to illustrate the basic architecture and approach and the philosophy, you can say as well there, right? Similar pyramid to what we've seen before. It all starts with the infrastructure. Of course, we need financial data. Here we work with quant models, right? That we might apply to financial data, where we have this as input, for example. We do simulation. Fourier pricing is required for the fast valuation of liquid vanilla options. Calibration, again, requires financial data in order to calibrate the models to market realities. Then once we have accomplished the calibration, we can take care of the market-based valuation of maybe exotic or non-traded derivatives, for example. And hedging is, of course, something also important in this context, depending on your position, depending on which role you're playing in the market. It might be the core idea of the whole exercise here in this context. So again, I would say this is the most theory and numerics heavy class that we have out there. Now it's time for the case studies. I have shown you already the Quant platform part, right? There is not that much to say about it. I refer you again to the YouTube video, to which everybody should have a link, right? I will now do quick demos, but by demo, I really mean I show you stuff and you will see it. You might understand many of the things, but sometimes you might say, oh, well, this is pretty new, interesting. Okay, I'm looking forward to seeing it. So don't try maybe to follow along live here. This is what I said before. Just have a look. But I thought I start with infrastructure because this is so important for everything we do. Then a little bit of a data science element, efficient markets, the idea, then model calibration, because in computational finance, we make use of efficient markets in a positive sense. Also DX analytics, just a quick run through, just that you have seen it. Then market prediction. This is something where we try to beat the efficient market hypothesis, right? Where we want to prove it wrong. And then I show you also how trading can be implemented. And last but not least, reinforcement learning. You see quite a few topics, every single topic pretty involved and covered in hours long instructional videos there with lots of code. But we need to get a start. And again, it's whetting the appetite to provide you with a flavor. And I'm getting started with the shell here. Maybe I increase this a little bit. And you see recently I have lots of dark modes here. And let me see here. I have already a line, Docker run TI. So I call the Docker container cert. Here I mount a volume. I also provide a port from the inside to the outside, or the outside to the inside, depending on how you want to see it. I run a Ubuntu container, and I want to run the shell. So if you say, well, I've never heard anything about Docker containers, well, this is something that you might find fascinating when you dive into the basics in the program. But what it allows me to do here, I'm on my Mac here. My Mac Mini is my desktop machine. And I'm going to run, when I start this now, a Ubuntu, a Linux operating system on my Mac. So this is one advantage. I can run different operating systems on my regular local system. But this Docker container provides you with a indeed containerized environment with a separate file system, a separate operating system, and the tools that I install. So typically what we do there is a little bit of housekeeping with regard to the package index, like what Windows does and Mac does more or less automatically when they ask you, do you want to update your operating system? I'm going to, based on the updated index, I'm going to do the update. I have a pretty new image, so not that much to be updated. And I can install like Linux tools, many of them. I don't know how many out there, in the thousands, I would guess. But what I need here is wget, for example, in order to retrieve something. And there's a question whether this can be done on Windows. Yes, this works the same way on Windows. I'm here on Mac running Ubuntu on my Mac. You can do this on Windows as well. So there are the instructions for Windows users as well as for Mac and Linux users, right? You can also run a Linux container, for example, on a Linux machine. So that's maybe not as exciting, but on Windows you can do that as well. So now I want to install, and let me check. I'm here in the root folder. I first go in my root. I'm logged in here as root, as you can see. Now here in root, I have only live, and when I have a look at it, this is my local folder, which I have mounted to the container. If I need this or not, that's a different question. This is just for illustration purposes. These are later the examples that I want to go through with you, right? So, but more important, I need to install Python, and usually I do this based on Miniconda. This is what we prefer, not Anaconda. Anaconda comes with lots of things that we usually not need, in particular for such a container world or a cloud instance. Here, Linux, I now need Linux, Python 3.8, and I copy the link address. That's basically it. I'm finished here. I'm getting back, and I'm now saying wget, and I retrieve the installer. You see this is some, I don't know, 70, 80 max, 80 or some 90 max almost. And I have downloaded the installer. So now I'm going to install Python. Here it says, welcome to Miniconda. In order to, okay, I press return. This is the license agreement. If you haven't read it already, you should, for the first run, read it carefully. I click through it. I've done this already quite often. And I'm going to install Python. You see all the packages that are installed. Now it asks me whether to prepend the path, and I say yes. And thank you for installing Miniconda. This is how far we have come. Now when I type Python command not found. Oh, well, yeah. Here it's a technical trick that I need to use. I need to restart the bash. And now you see how the prompt changes. Base, it says now. Before it was root at cert, now it's base root at cert. And when I now type Python, I have Python 3.8.3 from May 2020. Yeah, and now I can say print hello Python world, right? The hello world example. And my first line of Python, now executed. So I can exit the interpreter. Usually we won't work on the shell like this. What we would usually do is something like conda install, and I would install IPython and, for example, NumPy. No MKL is something that speeds up things a little bit. So what is IPython? IPython is a tool. NumPy is one of the major packages. No MKL is just a little helper package, a meta package, which avoids the download of large other packages. It shows me now what it plans to install. I would say almost always you type Y. Maybe you have compiled the list not correctly and you say, no, I need to redefine my command. But here in this context now, I have not only Python, I now have IPython available as a pretty powerful command line tool. What you see now here is that we have suddenly, as compared to before, we have also some syntax highlighting, right? This now looks a little bit nicer. And I have installed NumPy, so import NumPy as np. And with that, for example, np random, I can create random numbers, right? So you see, this is no magic. Maybe when you see it the first time, you say, oh, well, this seems tricky. But when you have repeated this, and this is what I mean by skill, this is from a certain point in time, I'm pretty sure for you as well, nothing that you will look up. Maybe some details. Of course, there are always, with everything that we do, there's specific details, specific problems that you might face. But for the basics, as I'm doing right now, when you say, well, I run a Docker container based on Ubuntu, the latest version, I install a couple of tools that I like there, right? Or that I need, depending on the situation. And then I install maybe some packages, some tools like IPython or NumPy, and then I should be good to go, right? When you say, well, here I'm in IPython, and you say what you read quite often, import pandas as PD, we haven't installed pandas, right? So this gives an error, no module named pandas. I can even from here, with an exclamation mark, I can say conda install pandas. So exclamation mark means that I escape to the system shell instead of IPython, and here I install this package, and now I can say import pandas as PD. That's fantastic, right? And then I can say something like df for data frame is PD data frame, and maybe something like np random, to use the example from before, random 5 and 4. So something two-dimensional. And df now is a data frame with column headers, with row keys, and with some random numbers, two-dimensional, from the NumPy and the array object. So as simple as that is, in many circumstances, the setting up of the infrastructure. So you see, even if you have never worked with Docker containers, once you know the basics of how to install Miniconda, you know the very basics of Conda, you should be good to go within the matter of minutes and not hours or even days, right, to set up the infrastructure. This all works locally. It works basically the same way in a cloud instance. Therefore, don't fear maybe new technologies that you have not encountered before. All is explained in detail, right? So Quant platform, Python with Docker, now efficient markets. This is now a Jupyter notebook that I'm going to open here, Efficient Markets, and you also have access to all these notebooks. And again, I'm not going to use this now as an opportunity to teach you that stuff. It's just for you to see some contents. I do some imports there when the walks are defined. I'm retrieving here some historical data. Have a look at the head of the first 5 rows of this data sets. And here info gives you a more detailed overview of what is in there. There's a question with regard to Docker versus Jupyter Notebook. The two technologies are not exclusive, right? So, for example, from within the Docker container, I could easily run Jupyter Notebook. I didn't do this now and use the containerized version. So let's say you are on a Windows machine, you run Docker, you start your Ubuntu container, you can start Jupyter Notebook or Jupyter Lab there, and then use via your Windows browser, you use Jupyter Lab with Jupyter Notebooks, for example, to do your analytics. So again, this is not exclusive. Docker, cloud, local, none of these technologies are exclusive. And usually we would deploy in all the environments as one of the major tools, not only IPython as before, but in particular Jupyter Lab today, which includes Jupyter Notebook server anyways. Here you see the data that we have, and we can calculate the log returns and have here the log returns now calculated. Of course, daily returns, pretty small numbers. And we can do some visualizations. I use Cufflinks here. Cufflinks is nice. It relies on Plotly. We see we have nice interactive charting. I can zoom in. I can go back out of scale. I can turn on and off here. For example, Amazon, when I get rid of Amazon, it's the best performing stock here. You see it changes immediately. So with Cufflinks, you have kind of nice visualization capabilities. Here you see now the histograms of the returns, right? Also with Hoover effects, and you see that they are all but normal. But this is a different story. Here you see the correlation matrix between the different returns, time series, and what I'm now doing here, and this is something you will see quite often in the PyAlgo part, is I prepare the prices as lags. Again, details later. 7 lags, and I do it for all my instruments. I have now 7 lags for all the instruments. And when I have a look at the data for Apple, you see here that this is the price from the 13th of January 2010, and this is from the day before, 2 days before, 3 days before, 4 days before, etc. So these are this is, if you like, the history, the 7-day history, or the 7 lags given this day. If we use now the regression, ordinary least squares regression, and try to use the historical data as a technical trader would do to predict today's data, right? So many people are sitting in front of their trading screens and they have all their statistics on the screen, like simple moving averages, RSI and whatnot, and of course the price history, usually in the form of candles, and they try to predict what happens next. And we do it here with ordinary least squares regression, where we take the lags as the independent variables and the today's price as the dependent variable. So we would say that let's see whether the historical prices somehow can be used to predict the dependent variable, right? Apple today. This would be nice, right? We apply it and we would have a good forecast, and then we would trade based on the forecast. But what we see here, and this is by the very nature of what I've implemented here, only lag number 1 has predictive power. So when I put this all together and I visualize this here, so when I visualize this here, so we don't need to have a look at the numbers themselves. You see this already, orange columns, they are the weights for lag 1. And what it says here is basically that only lag 1 is a good predictor, or the other way around, we don't need more than lag 1 to do the prediction, as good as we can get with ordinary least squares regression. And this is what the random walk hypothesis says, that the best predictor of tomorrow's price in the least square sense is today's price. And This is then when the conclusion is that, therefore, analysis of historical data doesn't make any sense, because if all the information that I can read out of historical data is already embodied in today's data, there is no need to analyze historical evolutions and price formations and whatnot. So more details on that in the algo class, right? And when we do the average here over them all, so these are the single assets, and we do it here based for them all. On average, we see close to 1 and everything else close to 0. We can also do this a little bit more statistically valid, where we see here the statistics. So just like for you to see that, yeah, here we have high T, P pretty low, and yeah, it's just lag 1 with a high coefficient here that is important. The rest can be neglected. So this is what we see here. There's a question with regard to Jupyter and Jupyter Lab. So what you see here is Jupyter Notebook running within Jupyter Lab. So this environment here with the file management, etc., is Jupyter Lab, but under the hood, it uses Jupyter Notebook. So don't be maybe confused at this stage between the differences here. Technically, I can say they are the same, but they're pretty close to each other, and you can run them pretty similar, right? These days, I would go with Jupyter Lab, and this is what we usually would focus on these days. Yeah, Cufflinks is open source for data visualization. It relies on the Plotly D3GS graph library, and as you can see here, it adds the iPlot method to the data frame world, right? So, but this is all open source, what I show you here. There's no paid subscription or whatnot involved. So let me restart and clear the whole thing and save it. So this about efficient markets. Now, in the computational finance context, option pricing model calibration, here the Merton jump diffusion model, we make use of efficient markets, because what we say in option pricing with regard to our parsimonious quant models is that we say the market is always right, markets are efficient, and when we see prices for liquidly traded vanilla options, then we can use them, this is here the calibration, we can use the prices, the market prices, to come up with the parameters for our model such that we can replicate the prices that we observe in the markets. So that's the idea in quant finance. We have a model, we have a couple of parameters, we try to find out the best parameter combination which minimizes the error to all the options that are relevant and that we observe in the market. So speaking of the options here, I'm picking out just a couple of these options. You see there is the date, so 2014, with much newer examples in the test projects. You will see other examples there, also in the practice modules from 2020, for example. There you see the strike, the call price, the maturity is pretty short maturity, yeah, just like 2.5 weeks, and the put prices. And what we are going to deal with here are call option prices, right? And we define an error function here. The error function is above here. That's we want to minimize by changing the parameter sigma, lambda, mu, and delta. We want to minimize this mean square root error, right? Root mean squared error. That's the correct RMSE, root mean squared error. This is what we want to minimize. And this is what this Python function defines. And once we have defined this, we first do, in general, a global optimization, where you see it's going through a set of parameter combinations which is fixed. There is no local intelligence to be used, like gradients or whatnot. And this takes a bit. It depends on the parameter values that I choose here, right? So the more granular I go, the longer it takes. And you see here, not necessarily, this is the root mean squared error. We don't see necessarily that the root mean squared error is decreasing monotonically. We might see some good results here, some good results there, because this is global optimization. So This is not really intelligent, but is brute force, right? By brute force, we simply scan the whole landscape, and once we are finished with the global scanning, we do local optimization. This is what is happening now here, where we take as input the global results, and now we use a local optimizer to fine-tune the parameters, if you like. You see, we ended up here with 0.970, and here we can decrease it further. I mean, I could work a little bit harder, but this is for illustration. So after the brute force optimization, we have ended up with this combination of the parameters, and this is after the local optimization, right? And now we can compare the market prices with the model prices, and you see that indeed our model is not too bad. The blue line are the market prices, the red dots are the model prices, and of course there are differences, but they are not too huge in absolute terms. So this is all in absolute terms. So we have €1 difference minus €1.50 difference. This is in relative terms. This is much more important than the thing that we see here. So often you would resort to rather minimize the relative differences than here what we do the absolute ones. But also this is covered in the respective class. But that's the calibration where we make heavy use in a positive sense of efficient markets. So efficient markets are our friend in the computational finance class. So DX Analytics, just a quick glimpse at what to expect there. Import DX, that's what we need there. We model a constant risk factor, a constant short rate. So here, and a bunch of risk factors. Here it's standard modeling, geometric Brownian motion, 1. And we can simulate and visualize the path. So this is traditional Monte Carlo simulation, all based on data frames with proper time series index, and a second risk factor with higher volatility. So volatility is 50%, before it was only 20%, here 20%. So we have a higher variability. You see here prices go up to 250, here it's just like 150 and less. Then we have evaluation models for an American option that we see here, American put option. And we can work with DX Analytics as if we would have closed analytical formula, right? Input present value. Now we calculate numerically in the back end the delta, the gamma, the vega of the option, the theta, and the rho. So the second one, this is now a little bit more standard. This is a European call option, and it behaves numerically the same. So this could all be calculated with Black-Scholes and the respective Greek formulas. But for the American option, there are no analytical formulas for all the derivatives. So we always need to resort to numerics, and this is what DX Analytics does out of the box, right? We can then put our two derivatives into what is called derivatives positions, and the two positions with their correlation and their environment objects make up the portfolio. And then we put this in a portfolio. See, this is the step-by-step modeling approach. First, the constant risk-free risk rate, then the risk factors that we can simulate, then the models for the options or the derivatives in general. Then we put them into positions, and the positions make up the portfolio. So it's all pretty much structured. And when you have gone through this a few times, I think and I hope this also feels like second nature. So here you get statistics, by default only a few statistics like position delta, position vega, but we can generate also risk reports with sensitivities where we disturb the factors here, for example, like 90% of the original factor value, and we see the immediate impact of the position and of the portfolio there, right? So here we see the level and how delta, this is not the net position changes. So let's say we have the risk factor initial value which is on a different level here, decreases, so it's 90% only, then the value increases by 13 in this context. So these are all net positions and net effect. So it's like a what-if analysis in this context. With the Vegas, we can do the same and the same analysis. So all out of the box, you see, with the calibration, we have seen like lots of code, because this is from scratch. We built the code from scratch. And here we have DX Analytics, which basically allows us to use similar, if not more, functionality from a package in standardized fashion. So now let's enter the arena of algorithmic trading. I said in computational finance, efficient markets are our friend. So we try to make a pact with the efficient markets and say, well, we trust, we believe in the markets, and that the prices of liquidly traded options that we see in the markets are the correct ones, and we'll make use of them. In algo trading, we try to beat the markets. So we say, well, even if you, whoever you is, tell me that the markets are efficient, I try my best to come up with strategies, with insights, with numerical methods, with AI approaches, which allow me to beat the market. And let's see how this might look. Again, just a quick run through, touching upon some basic ideas. Here you see I retrieve a data set, which was originally retrieved from Wanda. There's some 15,000 data points, goes from 2018 to 2019. Here you see that we calculate a bunch of statistics like volatility 1 and 2, SMA 1 and 2, momentum 1 and 2. We also work here with candles. So H minus L is the high minus the low. So we can model candles here and quite a few more things, right? So this is then up to you, to your imagination, vision, and research. And what I do here is I do a split at 60% for training, and the validation size is 15%. So I have, when I'm finished here, I have training data, validation data, and I have test data. I work with 10 lags, it's Gaussian normalization. And here I process the data. I have now 210 columns that serve as features. So I have basically all these, and I do a lagging for all these features. So this is how we end up. So with 21 columns, 10 lags gives me 210 here in this context. I can now apply a deep neural network, and there was a question which packages. For sure, we work quite a lot with scikit-learn. Here I use scikit-learn, the MLP classified as a deep neural network. 2 hidden layers, 256 hidden units, activation function, and a few more. And I do the fitting now on the training data set. It's pretty fast. So in many circumstances, scikit-learn and MLP, classifier and regressor, are pretty fast. And when I now implement the vectorized backtesting, we see here the first results. My underlying, which is, quick review, it's euro US dollars. So we are dealing with the currency rate euro US dollar. The underlying loses 3.3% and my strategy gains 4.8%. So we have 566 trades. Here we see that we are mostly short, so for long periods. And here you see now the green line, which is the strategy on the test data set. And the blue one is on is here the underlying, the passive benchmark investment. The green one is my strategy based on the neural network. But I must confess, this does not include transaction costs. So we have quite a few trades that we do here, but the costs to implement the trades, bid-ask spread in this particular case, are not reflected here in the results. So this is a net analysis. So no transaction costs assumed. Therefore, I would say this is not really realistic. I would assume with appropriate bid-ask spreads, and when we account for all the trades that we are implementing here, probably we are in negative territory. But I just wanted to show you how we, to a larger extent, try to fight against efficient markets, because this is our big hurdle. This is like the Chinese wall, right? We need to break the wall. If markets are efficient, then honestly, there is no point in dealing with algorithmic trading in the way we want to deal with it. Namely, when we want to generate alpha above market returns, above risk-adjusted market returns, and markets are like 99.9999% efficient, then, well, we shouldn't invest that much time. But efficient market hypothesis, it originates at a time when there hasn't been around that much data. In the end of 50s, middle of the 60s, going into the 70s, not that much data, not even to speak about intraday data, and not even to mention like machine learning and AI approaches, which are able to capture non-linear relationships, which traditional statistical and financial econometrics methods often cannot capture. So, but this is just like, again, another glimpse. The approach that you have seen now in a quick run through will be discussed in every single detail and in multiple different contexts. Wonder platform. Now you might say, well, I have finally figured out one strategy or 2 or 3 strategies that I want to deploy in practice. This is the point where you need to latest get into the world of the trading platforms. Because if you want to make money out of that, if you want to capitalize on your strategies, you need to be able to execute trades, right? So there's no arguing about that. There's a question with regard to when I talk about strategy. Was this? I don't really understand the question. Maybe let me explain. So when I talk about a strategy, this is a composition of long, short positions that are based on the underlying, right? The benchmark investment, not always, but typically what we use is the passive benchmark investment, right? Think in terms of the Apple stock. Apple stock is going up. It's pretty hard, I think, to beat the long-term trends that you see there. But think in terms of the Apple stock. So either you can say, well, I buy the Apple stock and forget about it, and in 5 years I have another look, or you say, well, let's try to capitalize on the volatility in the stock. So maybe if we have a prediction that says that Apple stock comes down, I go short, and if our prediction says the Apple stock goes up, I go long. So this is what I mean in simple terms by a strategy. The neural network in the context before made money compared to the benchmark investment by shorting the underlying. Simply, yes, think of an underlying which goes down, 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 right? If you are on the right side, meaning you short this underlying, you can, with every downwards movement, you make a profit in this context. That's a good analogy here. So let's have a look at Wanda. That's the platform that we use primarily for the AI machine in many contexts, or we have the masterclass, etc. So I import TPQA, that's our wrapper. I connect to the API. Here I show you the tradable instruments. So for my account, you see here there are some 125 some instruments. So there are quite a few instruments that you can trade, mostly FX and CFDs on stocks, indices, commodities, etc. So I'm focusing on Euro US dollar, running example. The data I'm going to retrieve is 2nd of September 2020, just recent, last week. That's the data that we get, 1395 data points, and here I calculate the returns. I implement a simple momentum strategy where I say, well, take the momentum for 6 returns here, right? And I take a rolling window of 6 minutes. So when we see window 6, we need to see here what the granularity is. And the granularity is 1 minute, right? Here, M1 is 1 minute. So we take 6 minutes. Swap NA, and I derive the position. So the long or short. The hit ratio, you see here whether we are positioned correctly or not is calculated. And you see we are more often false that we are correct with our strategy. So we have a hit ratio of 47%. That's not huge, but as a statistical stylized fact, we know that the hit ratio is only one side of the coin. We also need to get the larger movements correct, right? It doesn't help when I get all the tiny micro movements correct, the noise, so to say, when the market makes a big leap, a big jump up or down, no matter what, then we need to be on the right side. And therefore, we need backtesting. What we did before already, we calculate here. And the numbers are not like impressive. Again, no transaction cost. But here in this very simplistic case, you see, well, the underlying goes down over the course of this day here. And my strategy going long and short based on the momentum, much more simple than what we have seen before, goes long and short and has like a slight profit. But this is one day only, right? So when we talk about 0.5%, 1%, we need to see this in relation to the duration. So here we talk about, before we saw something about 1.5 years, this is now just one trading day, right? And when we plot this, the green lines now reflect the position. So when the green line is here on top, this is a long position, that's a short position. So you see here, it's a long, and then here it's long over that stretch, here it's short. So this is the change between long and short. So when we want to trade something like this, let me maybe open my demo account. I'm logged in already. So this is a paper trading account. Euro US dollar is open here. There is one open position, BCO, Brent crude oil, and I'm now going to place an order. This is now Euro GBP. I've just selected another element there, and you see I get immediately back this larger object here, this JSON object as a printout. And let me see. Oh, here's it, Euro GBP, a long position, 100 units, margin required is a very small position here, right? Price, the current price, and profit and loss in real time, both relative terms and in absolute terms, as well as in pips. So we have 3 representations. So I could now manually, usually I wouldn't do it, I could close here the position manually, but since we are in the algorithmic trading world and want to do this programmatically, I create an order now. Here was plus 100. In order to close the position, I place an order with minus 100. So let me see. And without, you just saw it disappearing and the position has been closed, right? I get the object here back, and when I say now print transactions, I see here, yeah, I tested it before. So 2 hours before, you see here the execution, and here you see plus 100, no P&L, minus 100. When I closed the position, I made the loss. I mean, there was not that much movement, but I need to pay the bid-ask spread here anyway. So I can place orders. And what I also can do, this is now related to connecting code. You might recall the pyramid. I can stream data. So it depends on the time of the day, whether this goes fast or slow. This looks pretty slow. So usually you retrieve like, let's say 3, 4, 5 ticks per second. This is now slow moving. I don't know if there is something specific, but this is in part also controlled by, you see here we get roughly currently only every 10 seconds. Now it was pretty fast, you see here. This is controlled, can be controlled by Wanda in particular for paper trading accounts, right? So here stream data, and we got the real-time data here. This is GMT time. This is given my local time here, 2 hours difference currently, since we have Central European summertime at this stage, right? But we get bid-ask spreads, bid-ask values here, and we can stream it. So for your reference, I'm not going through this in detail. There is another notebook I will just quickly run through it because in the final part, so you have access to all these codes and later on to much, much more. This is now a simple moving average based strategy. So when I execute this code, you see here simple moving averages is based on 5-second data. Here over the time interval, we see some outperformance. I'm not going to do the streaming, but what is done here, we don't have positions, right? So the final trade has been closed. And here you see like a code which does algorithmic trading. So I wanted to include this, although we cannot spend too much time here because it's quite a bit of code, but I can at least let it run here. And this is like a very simple example of an SMA-based algo trader class, which uses 5-second bars to trade an SMA-based strategy. It only trades for 75 ticks. This is for illustration purposes only, so it doesn't really make sense in a practical situation. But I just want to wait for the first trade. Here you see we have enough data. It now goes short. And here we have a position 1,000 short and maybe one more trade. I mean, it doesn't take too long, so maybe we wait it out. It now depends, of course, on the statistics, right? It depends on the statistics. There's a question here for the in order to get access to this paper trading account is enough. You don't need to pay for that. So even if you have a real account, you don't need to pay for the technology or whatnot. So this comes with any account, be it a demo account or paper trading account. This indeed, you see here it goes down. Euro US dollar is going down, so our short position now it has changed to a long position here. You see, because I mean the strategy doesn't really make sense. This is for demo purposes, right? 5-second bars, blah, blah, blah. But there is another trade. It reversed to the position. So you need a subscription, but it's not a paid subscription to answer. Yeah, there's somebody is pointing out that we have a US holiday, that's for sure, but Euro US dollar, for example, is most heavily traded in Europe, in the UK. So even if we have a holiday, of course, this might influence it, that's for sure, but we should see at least some movement, and we see the movement there, right? Yeah, but this is, again, there's another comment on the tick frequency. They limit the number of ticks that they can retrieve to 5 per second. So we are not talking about NASDAQ ticks for Apple, where you can have in half an hour more than 50,000 ticks, right? This is not what we talk about here in this context. All right. So just going through the questions so that we don't miss out for the questions. So basically, I didn't want to spend too much time given how far we are in, but you see now one run, right? Going short, going long, going short, and going neutral. Here's where it closes out. So you see, this is only in part magic, but it's not like the biggest code base probably that you have ever seen. There are quite a few lines of code and a little bit of trickery, of course, that's for sure, but be assured towards the end of the program, this will feel like second nature to you. Last but not least, just reinforcement learning, because this is so exciting. You see, I'm a big fan of it. So here for the card pool environment, we have action spaces. Everything is explained in detail in the reinforcement learning class and AI and finance. Action space, we have 2 actions only. Observation space, here are 4 floats. So that's the observation space, 4 floats. We can take action, move the card to the left or move it to the right. And here I provide you with a visualization. So that's the card pool, that's the card, that's the pole. And the basic idea is that the AI pushes the card to the left, to the right in order to balance the pole on the card, right? So this is what we want to achieve. But here, this is simply a random agent. This has no intelligence whatsoever. So it simply pushes left, right by random choice. But we can do better. We first reduce dimensionality to a single number. We devise an appropriate policy, which says if S is smaller than 1, A is move left, and if S is larger than 0, we choose A equal 1, right? And now we deal with the running of episodes. And when I run here, you see a random episode, random 11, 13, and the game is considered, or a run of the game is considered to be a success when we reach 200 episodes. 200 episodes, right? And here it's like, again, it's like 10, 15. So we hardly get above 20, maybe every once in a while, but never above 30 here in this context. Now we come up with, this is not really reinforcement learning. It's just to, again, whet your appetite. This is the starting example. I come up with optimized weights that I derive not systematically, but by sheer brute force. And here, see, with these optimized weights, I have now 100 runs with a perfect score. Well, we now have this agent, which is much, much better for sure than the other one. It will run here, you see, 200. So it runs at the state a single state. So a quick run through, unfortunately, not being able to go into the details. You see, you know this. I would like to, but time doesn't allow at this stage. So watch out for more to come in the respective classes there. But the card pool game, it's usually an introductory example, and we use it in the very same way as an introductory example. So I clear up all the codes here so that I end up with empty Jupyter notebooks. I clear up all the codes, and we have finished the final. And maybe a little bit of housekeeping, I can now shut down all the Jupyter notebooks. You don't have to necessarily, but I think it's good practice to do so. So let's get back to my overview. We don't need the platform anymore. No trade active here, so I can close Wonder web interface. Simple examples, but some of them, you have seen the codes, might look pretty involved, but of course we lead you to all the codes that you see there. It's nothing like a cold water pool where you need to jump into. We start with hot water, and then we get a little bit colder, maybe lukewarm first, and then you will encounter many of the things at a much later point that I've shown you today. So there was a question, how to best start, where are the starting points? And this is now where the study plan comes into play. You have the link to it. It is publicly available. It is updated at least on a weekly basis. And here you see it, week number 1. This is like the red frame. There's also a link here behind the screenshots. Finance with Python, and I've shown you the videos Finance with Python. I've shown you the text Finance with Python. I've shown you the codes Finance with Python. And Finance with Python 1 and 2 are your starting points there. We have, of course, live sessions. I typically highlight them in red here. You should have retrieved invites. Then there are financial data science, data types and structures, tools and skills, number 1. AI in Finance 01, live plus video. So we have here the one live session, but you also have video. And if you like, this is optional, you can get started with Python for Excel. But you can, of course, do Python for Excel also later on. But from the optional material, this is, I would say, the most simple class, given that many basics are covered there as well. So speaking in terms of starting point, this is your starting point. The first week, you should cover Finance with Python in any case. In all the live sessions, if you can make the live sessions, the recordings will be available at the same day later at night, because it takes always to convert the videos, or latest the next morning when videos take a little bit longer, right? And then you should go through there from left to right. So you should cover this. In any case, if you can make it to the live sessions, I think that's pretty helpful. And then you should go from left to write. Right? Next week, same thing. You get an orientation email. I will do the highlight. I will put in the live sessions, etc. And we will add tutorials here as well. So every week has its tutorial. There is, in the meantime, before we move on, because this is related to algorithmic trading, there's a question with regard to MQL and all these environments and questions with regard to MetaTrader and the individual questions. We won't use any algo trading platform that are connected maybe to CFD and FX brokerages. Our program is a Python program, and Python has become the language #1 in the finance world, as well as in the algo trading world. All the big systematic hedge funds, they all use primarily Python. And by primarily, I mean as a strategic platform. And there is obviously some benefits of using this in this particular context, but I'm pretty sure once you're in a week 2, 3 in the program, this will become much more obvious. Even if some things might seem out of the box more simple other areas, but you gain a lot more power and much more flexibility. Just think in terms of a neural network that you want to apply with MetaTrader to your data. Doesn't work, period. But that's just one aspect, right? Let me see, we have more questions. There was one question was indeed with regard to where to best get started. And here, the red frame is your guide for the first week. This is how to get started. Start with Finance with Python. I've explained to you before in detail how to access all the resources in this context. And yes, with regard to the next question that I left open, because we have the point on the agenda, are review questions, exercise, and test project. So we have review questions, and the review questions are structured in a way that you can say basically every 3 weeks we reach another milestone. So after week 3, when in week 4 the core classes begin, I usually see the first milestone. And here you see review questions for algo trading as well as the computational finance part, which help you in reviewing the material and which help you in seeing whether you have a good grasp of the topics covered there. But they are more like, an interactive way for yourself, but not really about coding. There is no question which says, well, code X, Y, that. This is where the exercises come into play. And we have the exercises, and from next week on, we don't start with tutorial in the first week. So basically you can expect in the second week exercises and test projects which cover topics from the first week, right? So from the second week on, you have such exercises here. Finance with Python, it's the header here. It's about arbitrage pricing. You get like initial situation, and then you get a question. What is the strike price of the put option? Which portfolio replicates the put option payoff perfectly? Is there a difference when using or less regression? How can a learning algorithm be used to replicate a payoff? You also have test projects. Some are fun, some are really related to the topics. And as you go, we have also, this might be not of interest for everybody, but I know for many it will be, like typical interview questions that you might face when you go for a job interview or for an admission test at a university, and also typical cases that you might encounter in such situations. So it's not only standard, like every week the same thing. So there are different modes where you can test yourself. And then, of course, we have the practice phase with the modules where you should send in reports, where you should do the stuff on your own, because you can master every test out there. The real proof lies in you yourself putting it all together and putting it all up in the cloud, let's say. That's the real thing, and see your strategy going long and short, or see your program calibrating to most recent option data, right? So you have this. So a clear yes, this is all there, and you can do this on a weekly basis. But I wouldn't worry too much in the first week. From next week on, you can work on the exercises. There's a question with regard to a specific one with regard to the week 3 financial data science. This is something which subsumes a couple of topics that we cover here in financial data science. So here, this is a specific session which goes into some details that I consider important moving forward. This is like if you like, a summary session, which provides a common ground for what is up afterwards, right? So it is a little bit of a bridge between the purely theoretical parts here and then working suddenly, quote unquote, with real world data. So here we go in much more detail in this regard. But this financial data science, this covers the basics of the basics for financial logistics, as I like to call it, so that you get a good handle on the data. Good question. So the user forum is your friend. So whenever you have a question, I say, well, in this Jupyter Notebook, I don't understand X, Y, that, or when I wanted to install a package, why it didn't work out for me. So user forum is your place in this context. So there's a good question. Will there be some Slack? Or frankly, I'm not the biggest fan of Slack. So my whole life I've avoided it because I think this is frankly, from my point of view, maybe other people think differently, unnecessary overhead. So for organizational topics, there's always the email channel for sure, but for all technical topics in a searchable way, and usually there is not like the need to be online 24/7 to answer stuff. So when you work asynchronously, as I see the user forum, I think you get the right tool for the typical technical coding question, because in the user forum, you have the options to highlight code, to add screenshots to here, and you have a searchable database. And we have all the automatic stuff that helps us managing it. Like we get automatically notified by email when there is a new post or when there is a new reply to it. We can answer by email. Again, I said it before. For example, you can use the user forum from the iPad or from the iPhone or any other phone to this end, just via browser. It should work mobile, maybe not like to 100%. It's primarily a desktop-based platform, but it should work there as well. But we can discuss this if there is enough interest. I'm willing, what I've done in the past as well, for example, to open a Hangouts group if we see the need for real-time chat communication. But again, you cannot post there really codes and stuff like that. In that sense, I'm open for discussions in this regard, but the user forum is what you should get started with in any case, and you will see this is, from experience over years now, a pretty efficient way of communication when it's about technical topics. There's another question with regard to the optional class Python for database. I mean, everything that you do from the optional part will help you in other cases, but I wouldn't necessarily say that you need to cover PyDB to better understand pandas, which the question is about. But if you say, I want to use pandas to interact with relational databases where pandas is pretty strong, then for sure you will have a benefit, but not necessarily for pandas and standard approaches there as well. If you post something in the user forum, please make sure that we can help you, right? This means, and here is the link, and this is maybe one of the most important links from this presentation, how to create a minimal, complete, and verifiable example. We so often have it that people say, well, dear team, I went through session 4 of the X, Y, and Z class, and when I tried to replicate what is done there, I failed. Can you help? So this is like a problem for us, right? So what exactly, where did it fail? What did it do, right? And usually I'm on alert when somebody says, I do exactly the same thing as you do. This might be the case, but it doesn't help in debugging. So always make sure that you post a minimal, complete, and verifiable example. And often when you go through these questions and through this little post, I have the experience, and many people mirrored that I said, well, once I tried to come up with such an example, I was able to figure out it all on my own. This doesn't mean that we try to prevent you from it, but sometimes we write back and forth like 5, 6 questions to clarify what's going on. And this doesn't help you when you need the help. And it might delay like the solution of your specific problem to quite some extent, right? PDF books are currently 2 there, so everything else is HTML based, and the books are coming out. So that's the current state. So you should have retrieved the passwords for the 2 PDFs. Yeah, the passwords. There's again a question for the PDFs. So everybody who has received A, the personal welcome email, B, the login credentials, in both emails, there are the passwords for the PDFs. So they are red. In both emails, they are red for better visibility. And for computational finance, it's not only for computational finance, it's optional. So I would say AI in finance is of interest to everybody. But if you really want to focus on the option pricing, hedging, calibration side, numeric side, what you will encounter in AI in finance is not the core stuff that you will need there. So in that sense, it's optional. If you say, I need to prioritize at this point in time, then I would consider it optional. But on the other hand, most people or many people come to us in particular for these topics related to algorithmic trading. So in algo trading, I wouldn't consider it optional, but in computational finance, you can say, oh, well, time currently doesn't allow to cover it, so maybe I cover this later. Interesting stuff, but maybe not for what I need at this point in time. That's for sure. Yeah, there is, in terms of like the Slack discussion from before, networking, of course, it's a fantastic thing. You can do it on the platform. You see there a couple of entries where people say, well, I want to form a working group who is interested in joining. So if there is interest, I can coordinate. But usually what we don't share like the names or email addresses of the members. This is due to data privacy and protection, right? But you can post, for example, something in a user forum, and people can then, of course, reach out and say, well, I'm interested, let's meet here, there, or do stuff together. I'm completely free for that, but we cannot like share with a single or a group of delegates the addresses with other delegates, right? All right, the final topic, close to the end. The importance of practice. And here since quite a while, I'm quoting here Anders Ericsson from his book, this co-author Peak Secrets from the New Science of Expertise. When you look at how people are trained in the professional business worlds, you find a tendency to focus on knowledge at the expense of skills. Of course, you can have like a gazillion of books on your shelf. You might have read them at a point in time, but I share here the view. I believe the best approach will be to develop skills-based training programs. This is how you should approach this as well. It's not how much you have covered, it's how good you are and what you have covered, right? This is like, when you go to a piano lesson and you want to master the piano, you want to learn to play this fantastic instrument, you can listen to your teacher all day long. You can listen to YouTube performances, you can listen to DVDs or MP3s or Spotify programs about playing where the piano plays the major role, but you need to train yourself, right? You need to exercise. You need to exercise your scales. You need to exercise the scores of the songs that you want to master, right? Therefore, training should focus on doing rather than on knowing. So we provide lots of theory. You have seen we have grown the theoretical base of our program tremendously to 1,750 plus pages. That's quite a bit, but trust me, even if you haven't read it all, but you have mastered 10 core skills from the program, you are better off than maybe somebody who has read everything carefully, but who has never programmed a single line of code. This is like swimming, right? You read a book about swimming, but there is a point in time where you need to practice your swimming in the pool. You need to get wet. You need to put in the hours. What do you want to do? And some topics might seem complicated, difficult, hard to master, but this is like the good message, for me at least. No matter which area you study, music, dance, sports, competitive games, or anything else with objective measures of performance, you find that the top performers have devoted a tremendous amount of time to developing their ability. So you might say, well, that's a bad message. I need to put in tremendous amount of hours to master it. Yeah, but everybody who masters something has put in the hours, be it tennis, be it golf, be it chess. And the same holds true for programming. You won't see a master programming guy out there, black belt, Pythonista out there, who has just spent like 50 hours of programming. You have a good systematic, comprehensive starting point with our program. And again, you should focus during the time that you spend there on the skills. You should read it, you should try to understand it, but the most important thing is to do it on your own, to replicate it, and then to run on your own, to come up with your ideas, to test it, to pick your projects and try to implement them. If you miss details, you can always pick up details on the way, that's for sure, right? So, and this is also an older quote, what I always am striving for when people do our program. Here, Elvis put it to the point. I liked watching your videos, but it's much more interesting and educational to actually build something on my own. This is how you should approach it, right? You should watch the videos for sure. You should read the text. You should go through the codes, but to build something on your own, I think this is like what gives you enjoyment and satisfaction and differentiates you from all the others who might have heard about some different techniques and technologies and tools. But if you were able to master them, maybe after the program on brown belt level and then move on towards black belt level, this is what I would wish for, right? In that sense, we are through a little bit longer than planned for, but you see there are quite a few things that we're going to cover, quite a few aspects to touch upon. I wish you at this stage the very best with getting started in the program and with acquiring as many helpful skills as you can over the course of the program. I'm excited about the new cohort and the stuff that is in front of us. I hope you are as well. And I say take care. I see you in the next session. Bye-bye.